Welcome back, everybody. Good to see you. Let's see how we're doing here. I had a couple of corrections from last time. First of all, I want to just, there was some confusion towards the end of the day when people were starting to get their teeth into the notebooks. And they wound up noticing that sometimes you could download the notebook and then you'd bring it up and then it just wouldn't even render at all inside of your web browser. That's because there was a version change from version 2 of the notebook to version 3 of the notebook, as IPython itself went from 0.12 to 0.13. Unfortunately, the latest EPD distribution is 0.12, so the vast majority of you, I think, are using what you might call an old version of the notebook. The new versions of the notebook will be able to read the old versions, but the old versions don't know how to read the new versions. So accidentally, we posted a couple version 3s and not version 2s of the notebook. So if you're having trouble, it's not you, we just posted the wrong version. What we're going to try to be diligent about, and you see Eric did this already for the solutions, is to post 2 different versions of the notebook. If you're using the latest IPython 0.13 or 0.14, you're fine to pull up either of those. If you're using the EPD distribution, make sure you get your hands on the version 2, okay? And if you find out that we haven't posted the right one, just let us know. The other one is I impugned the state of Kansas yesterday, and I apologize for that. I got an email from the governor, and you as well. It was actually Indiana that tried to pass the Pi bill. And it wasn't 3.0 that they tried to say Pi was, they said it was 3.2. It almost passed. So I apologize to everyone from Kansas, but now I'm looking at you, Indiana. Okay, so here's the plan of action for today. We are already a couple minutes behind. We'll try to catch up a bit. We're going to talk about strings. In some sense, we kind of powered through some of the real basics of the Python language yesterday. And then we got into some interesting stuff like plotting. And these are considered sort of outside of the built-in core language. We're going to come back into the core language in the morning and really spend most of the day sort of teaching you some of the more advanced concepts that exist within Python. And then tomorrow, we'll get back into some of the more advanced stuff that lives sort of outside of the core language. So this morning, we're going to do advanced strings and file I/O. We'll do some advanced stuff, just sort of a grouping of things that we think you should know that weren't in any of the other modules before we do the first introduction to object-oriented programming. Then we'll have a lunch and a breakout. We'll do another incarnation of object-oriented programming, getting into some of the nitty-gritty of that. And then we'll end the day with some software carpentry, a discussion of development of your code, versioning of your code, and curation of your code using the thing that we all use, which is called Git. Okay, so let's jump right into it. Strings can do operations on themselves. You've already started to see this concept of a method, but now we're going to see what strings know how to do on themselves. So if I have a couple of different methods on strings, one's called lower, another upper, another capitalize. Funky town, you see I spelled that, or at least capitalized that in a weird way. You can say dot capitalize, and you get funky town. Here I have another funky town. I can put it all to lowercase. I can split up strings very nicely and elegantly. If I just say funky town and I say dot split, it splits on something. There's a default. There's a character that it splits on. It's basically it's a space. So every time there's a space in your string, it will split there. And what did it return? What type of object did it return back to us? A list. A list, or an array, if you want to think about it. But it is technically a list. So I could iterate over that list if I needed to. You can daisy chain these methods, right? Because the result of having return capitalize is a string. And so I can, if you want to think about it this way, what's happening is you've got the result of what's ever happening inside here, then getting returned into a new string, which is then getting split up. You can use the list comprehension that we introduced yesterday to go through and, perhaps sequentially capitalize each one of these. So you notice, if I said funkytown.split.capitalize, the result of funkytown.split is a list. .capitalize is not a method of a list, and so that would fail. So if I really want to capitalize each one of those each one of those words in turn, one way to do it would be to start off with the string, split it up, and the result of that is a list. We iterate over that list, and as we step through each element in that list, we basically fill up this variable called x, and then we wind up running the capitalize method on that, and then you wind up getting a new list that comes back where you've capitalized each of the words in turn. I want to take you to Funkytown, and now I don't want to split it on all the spaces. I want to split it on something else. I want to split it on U. And so what you wind up seeing is every time there's the letter U, you wind up removing that and splitting on that. So now I've got I want to take yo to F town. What if I want to split on not just an individual character? I want to split on a string. I can do that as well. And it says I want to take, and then you notice that it's preserving that space right there to Funkytown. Yeah.
Can you split on the character can you keep the character you split on?
No, you can figure out sort of very succinct ways of pushing it back on when you actually, if you want to say rejoin the strings or something. But no, effectively what you're doing is saying use that to cut stuff. And you can imagine why this might be helpful, say, if you're parsing through a CSV file and you didn't know about CSV to rec, you could go line by line and say split on commas. Or if you know that your CSV file is tab separated, you could say split on /t. And here we go. So here's a CSV string. Dog, cat, spam, defenestrate, 1, 3.14, and then some other stuff at the end. So we could say CSV string.strip. And what does strip do? That's something new. That just removes all the trailing and leading white spaces in a string. So that's kind of nice if you want to clean up individual strings. Now, let's say I want to clean up that list a little bit, and I want to make, I basically want to make sure that I don't have extra spaces after I do my cut. And so I have my clean list, and what have I done? I've taken CSV string, I've split that on the comma, and then I will wind up iterating over that and making a new list. What does clean list look like? It looks probably something similar to what we want, right? So now you can deal with each of the elements of this. So, one way to think about you parsing foreign data is that you have to be pretty robust against all the little quirkiness of that data. And so this is actually pretty easy after you've played around with a couple lines of a piece of data. You'll wind up realizing, oh, there's all this stuff at the end. I don't really need that. I can get rid of that. They've added all these extra white spaces, which isn't really nice. And so, this is part of you getting familiar with the data sets that you're playing with. This is mostly in kind of reading stuff in. There's similar kinds of things you do when you write stuff out. In particular, there's something called join that allows you to glue a list of strings together with a certain string. So now I've cleaned up that one line of CSV, and I want to do something with that. Let's say I want to write back out a cleaner version of that CSV line. So what you can do is you can say, here is some string, and join it, basically use that to essentially act as glue between all the elements in this list right here. So it's almost identically opposite of split. Here you basically say what character you want to use to do that glue, and split you basically can say what character you want to do the split. And here you go, a nice cleaned up version of that CSV line. Yes?
Can you include spaces in there?
In where?
I need commas and spaces.
Yeah, if you wanted commas and spaces, you could do that. If you wanted to separate everything with a /n to have everything on a new line, you could do that. You can put anything you want there. You could also have that be an empty string, so you just concatenate all the elements together. What do you think the nature or the type of the different elements have to be inside a clean list for this to work? String. What if you weren't sure if clean list had only strings in it? How could you sort of, without having to write a new array and stuff like that, how could you deal with that? Someone raising. Yeah, there. What's that? STR, but what does it mean to do an STR on a list? So close.
4x.
Yep, you would do a list comprehension, right? You'd say, bracket str of x for x in list, right? Close bracket. You can just shove that in here to make sure that you're definitely getting a string. So here's a way if we instead don't want to do comma separated output, we want to do tab separated output with a \t. We can also go into strings and we can replace stuff within them. By the way, remember I said yesterday that strings were immutable. That is still the case. What's happening when we're replacing characters and things within strings? Well, Python's saying, oh, you want me to replace this with that? Fine, I'll do that for you. I'm just going to return to you a new string. So you're not actually going in like you do within a mutable object like a list. You're not actually going in and inline essentially changing that element in that list. You're actually creating a new string. So .replace is a method that works on strings. And here here's my CSV string. And what am I going to do here? I'm going to strip all the bad stuff off the back over here, and there's nothing up at the front. And I'm going to replace all the spaces with a comma. So I pretty much got back what I did in the few lines above it, but in a very different way. Are there any questions about that? Yes.
Actually, you're replacing the spaces with a no space.
Oh, sorry, yeah. Yes, correct. I'm replacing spaces with no space. Thank you. Yeah. Okay, and here I'm replacing the no spaces with the spaces with a no space, and I'm replacing the commas with a \t. So that gives me my tab separated version of that. Everyone clear what's happening here? Sort of daisy chaining these methods. Should be clear what's sort of the ordering of this as well. Okay. We can do some introspection inside of those strings, and find, as you'll see, or find, is incredibly useful for searching. What you get is an index of the result of that search. So if I have a string called My Funny Valentine, and I ask for where is the character y, I get the number 1, because S is 0 index, so M is the 0th place, and Y is at the first place. And again, you notice, just like when we were doing lists yesterday, that if you ask for the index of an element whose value is something, you don't get back all of them, you get back just the first one. S.find y, comma 2, what's happening here? Well, what it's saying is start your search at index 2. So for instance, if you absolutely needed to loop over every single string, there's obviously sort of nice packages that do stuff like this for you. But if you had to really, really go into every single string and look for certain characters or certain snippets of string in there, one way you could do this is basically start at 0 index and just start looping through your string. Find the first instance of that, perhaps save that index, and then start at the next value. In this case, I had 1, and I start now at 2. I start my search at 2, and you just keep on going until you get to the end of the string, right? If you really need to do something like that. Okay, what is this doing? Well, think about the ordering in which this operation is happening. S.find funny, that's going to find the index where the word funny starts. So it's going to be 0, 1, 2, 3. So 3 is going to be replaced here. And then I have the colon, and then I have nothing after that. So I'm going to start at index 3, and I'm going to get everything after that. And I'm going to just return that part of that string. And what happens when I say Z? There is no Z in Funny Valentine. Anyone have a guess? -1. This is one of the quirks of Python. It could have said none. They could have made that decision, but instead they decided -1. So typically what you'll wind up seeing in code is that if you're trying to find, let's say you want to know whether the line that you're looking at is a comment line, you'll say, and you know you want to loop through all the comment lines, you don't want to have to deal with them. You might say, while the string that I'm reading, dot find, and then whatever the comment, let's say it's a hashtag, is not equal to -1, keep on going. Yeah?
That's a weird choice because that happens to be the index of the last character also.
Oh, right, yeah. So if you want to now use that and you say, let me grab the result of that search and see what character that is, you're absolutely right that would be wrong. So it is a weird choice. Does everyone get that? Right. So if I have a string.
Did we also find out yesterday that you can't go backwards in a string?
You can go backwards in a string. So here's a string, and now if I say the index is a find z, that's -1, but if I say a of I get y. So this is what you're pointing out is weird. So you have to be a little bit careful about what you get back from find.
So then if you put a requirement saying, you said like if you could put something saying, loop over unless it's say -1, then it's also going to miss that last letter every time.
Say that again?
You said in code you could put that you don't want to continue the code if the index equals whatever find z. But then it's going to miss the last letter.
No, because the last letter also has a meaning. So if I go to if I say the length of a, right, is 5, and if I say a4, I get y. So if I searched for y, I'd get 4. I wouldn't get -1. There's just something special about the -1, right? The -1 makes it painful if you want to just use the result without actually knowing what that result is. Yeah. Was there a question over there? Okay.
Can you use strings in double quotes and objects? Can you use the methods on it?
Yeah, so the question is, can you use strings or double quotes? And the answer is, and use methods on them. So if I just said, hello, and then I could say split on hello, because I'm Cockney. That just works, right? It doesn't have to be a variable. Is that what you're asking? Okay. Okay, so now we have a list of strings. And the first element of that list is my funny Valentine. Next is Argentine, American, Quarantine. Now we'll loop over that list for the string in SS. If the string finds time not equal to -1, that is, it's in there, print basically the string contains time. My funny Valentine contains time, Argentine contains time, quarantine contains time. You try to say that at home. So what are we missing out here? We're missing the American, because as I loop through these strings, I wind up asking the question, is the occurrence of time inside of that string? If it is not, I will get back a -1. So this is sort of an example, a very succinct example of how you would use the find to sort of loop through all of your different strings. There's also some useful variables and functions. So if I say import string, I get access to some nice functions. So these are not necessarily methods on a string object, but these are functions. I can swap case. So I've got a lowercase f and a lowercase t, and I just want to switch that around, and I get back what we did at the very beginning. I've got access to all the ASCII letters. So if you're looping through and I say, is this an ASCII letter that you just gave me? You can just say, is this character in the ASCII letters? And that's basically just a very long string. I can get digits. So I say, is this character a digit? that kind of stuff. Okay, we're going to look at this thing called check email now, which is going to allow us to parse through a couple of different emails. And all this is going to wind up doing is just looking at an email address and tell us whether this is a valid email address or not. Okay? So I think this is, if you reload the agenda, this should be up there right now. You can pull this over and you can play around with it. Let's just take a look at it. So at the top, I'm importing string because I'm going to need some access to that. Here are the domains that I'm going to allow myself to have at the very end of my email. And there's some disallowed characters, because I know about this in emails. We're not allowed to have a dot, and you are allowed to have a dot, but all the other things that are punctuation are not generally allowed in email. What does it mean to be punctuation? Let's just check that out. Forgot. That looks like Charlie Brown speaking Lucy. So all that stuff isn't allowed. We're gonna handle the @ sign gracefully. But what you see I did here, where I wound up replacing the dot with the empty string, I basically said I don't want to know about any of these things in my email address, but I will replace the dot with the empty string, which is just saying it's okay to have that dot. And you notice that somewhere in the middle, around there, the dot is now gone. Okay, I'm going to loop through, and I'm going to ask for an email address. This won't work in the notebook, of course, because they don't know how to do standard in yet. I'll strip out whatever I get at the end just to make sure if the person added like some escape character, or in pressing return, it actually made its way into the string that I got back. I'm going to count the total numbers of @ signs, and as you know, there should be only one of those. If it's not equal to 1, I'm basically going to say, sorry, you have to have 1 @ sign. And then what does the continue do? It just says, forget about all this other stuff, just go back to the top. And what's that going to do? It's just going to ask for another one. Username and domain. This is where I will now use the split method on that string, and I'll split on the @ sign. So now I've got everything on the username side and everything on the domain side. First, we look at the domain side. We're going to look for a dot. If there is not a dot in there, there has to be at least 1 dot. So you can't just have, Josh at Berkeley. It's got to be Josh at berkeley.edu. You have to have at least 1 dot. If that's not there, then we have to return back. What else are we going to look for? We're going to make sure that the last part of this is the correct domain. So are we allowing .coms? Yes, we're allowing .coms. That's fine. So let's say I've got Josh at Microsoft.com. I'm going to split on that and on this dot, and I'm going to take the last element of that. So that's the last, whatever the last characters are after the last dot. You notice here there could be multiple dots, but I'm saying I don't really know or care how many of those dots are in the domain name. I'm just going to look at the last bit of that. Okay, so if it's not in there, so how do I ask that question? If it's not in the allowed domain names, it's really got to be in there, then I say So we're good to go, and you'll see why we need this later on, because I want to catch all the errors that could happen in the username. So if we've got disallowed characters, basically here's the disallowed string. That's the thing that we constructed at the very top. I want to say, no, we're not allowed to do this. But we're continuing because we actually want to catch some other errors if there are any others. We're here, then we're in a good domain, and we want to now check the username and make sure it doesn't have any invalid characters. And then if we're good to go, we say we've got a valid email and we're done. So we're making use of a bunch of the different concepts I've already showed you this morning, and this construct of the while loop that we had before. By the way, you notice I don't have any doc strings in the previous one. That's bad. I should have doc strings. So, do as I say, not as I do. We try to put as many doc strings as we can, but just to put it all on the screen so we can read an entire code in one go. Sometimes we leave some of that stuff out. Okay. All right, so let's play around with the check email address. You can try this. Type Python check email.py within, basically within one of your terminals. You can also, I believe, type run check email.py within IPython. Not within IPython notebook, but within IPython. So let me try a bad email, josh.python.org. There are no @signs. So it goes right back to the top. Here we've got our @sign, but we don't have any dots. So that's an invalid domain name. Here, Josh rocks at python, .org. And I've caught all the bad characters. Josh rocks at python.org. Valid email, thank you. Okay, any questions about sort of parsing strings? Looking inside of strings, dealing with what you find? Okay. So we'll talk about string formatting. Yesterday we gave you a breakout session where we asked you to sort of make nice column formatted outputs from this airport example. And we didn't really give you all the tools that Python has to do this stuff fairly gracefully. There you had to basically coerce it and count the number of characters in the input string and then pad out all the sort of extra missing space with actual spaces. So there's nice ways to do formatting, just like you get in Fortran or C. And the typical usage that you wind up seeing, oh, this is changing a little bit, is you have quotes, could be a single quote or a double quote, and then you have a % sign, you have something about the format, and then afterwards you have another % sign, and then actually a tuple. So it's a variable, comma, variable, comma, variable. So we'll show you examples of this. So my favorite integer is this % sign I. That's obviously not an integer, so that's telling Python, when you're parsing this, this is something special. You're going to have to fill this up with something else, as you'll see later on. And my favorite float is, now here's this f, % sign f, that's saying printed as a float, which to 3 decimal places is .3f. And in exponent form is whatever, % sign e. So my favorite integer is 3. My favorite float is math.py, math.py, math.py. Python will do its best to basically coerce the results of this output for you as makes sense. My favorite integer is 3. My favorite float is this, and there is a default for how many in a float get printed out after the decimal place, which to 3 decimal places is 3.142, and in exponential form is 3.14 blah, 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 e, etc. What are some things that you notice about how this got printed out? It actually rounded for us. Right? So Python says, okay, when you're printing out a number that's a float, or you're printing out a number that is in exponential notation, and you're saying, just show me the first 3 decimal places, it says, well, you don't just want to see those as they would be represented if I sort of rendered the whole float, made it as a string, and then just cut it off. It actually says, oh, what you really want to do is you want to show this as best as you can, and therefore it's doing the rounding. So this very succinctly shows you the different ways in which you can get access to different types of formatting. If I had said math.py instead of the 3 here, what do you think would happen? I actually don't remember, so I'm going to do it. What if it was, what is math.e? Right, it didn't do the rounding for us. At least it didn't round up for us. So when you do this integer printing, you got to be very careful, right? I believe when you do integers, it always does the floor of the integer. But when you're asking to render a float, and you're asking it just to show a certain number of decimal places, then it does what you think it should do. Any questions about that? We're not going to have time to go into all the different types of formatting. I'm just trying to scratch the surface here to show you that you can do these things, and it's actually pretty straightforward. I have a link at the bottom. You can replace the 2.7.2 with 2.7.3. It's basically the same and hasn't changed much. Okay, if you actually do want to have a % sign inside of your string, you have to tell Python, by the way, this is not a special character anymore. And the way you do that is you wind up giving it a double % sign. So I promise to give you 100% effort whenever it's asked of % sign s. Now s is a string. We can do 0 padding. You see I have basically a bunch of different ways to do this. You can use this as a reference point. We have % sign f, so that's just saying show me the float. \n, so I'm going to get a new line. Then I've got a then I've got a % sign plus f. We'll see what happens there. And then a % sign plus f \n, 0, 1, 0, f. You'll see all these different types of format. And we can try to figure out what it's actually doing for us. All right, let's start from the back, actually. Here's 10s. What do you think that's doing? It's printing out the word pi. It's just padding, right? It's making sure that there are 10 characters as what appears on this line. What's the next one doing up here? This is doing some padding as well, making sure that we've got 10 spaces and it's 0 padded out. So it prints it in this funny way. Very rarely would you need to print it that way. Let's see, I had a minus sign right here. And you can see that if I have a minus sign, I basically will always show, using this plus, the minus sign. But if you don't have a minus sign through this first incarnation of the % sign f, you don't see the plus sign. But let's say you really do want to see the plus sign. That plus says, OK, I'm always going to show you whether it's positive or negative. OK, so that's one way to do string formatting. The other way, which is sort of the Python 3 way, so it's not a bad way to learn now, and it works just natively in Python 2.7, is where you this kind of looks a little bit more Pythonic, where you have a method that operates on the string, and that method is now called format, and then you have value, value, value afterwards. So just to be clear, before, what I have here is some string, and that's basically the formatting string that I want, plus anything else inside that's not going to get formatted. This weird sort of % sign, which doesn't look Pythonic at all, and then a tuple that comes after that. Here's how we do it now, but as you'll see in the bootcamp, we sort of go back and forth between the different ways of doing these types of printing. On, and now with these little curly brackets, on 0, comma, I feel curly bracket 1, and I'm saying dot format, and I'm giving it not a tuple, I'm basically just giving a set of arguments. And here we have Saturday groovy. On Saturday I feel groovy. What's happening here? Well, the formatting is saying, whenever you've got these little curly brackets, it's saying, grab the first argument, that's what the 0 says, grab the second argument, that's what the number 1 says. So it's saying, ooh, I'll pull Saturday into 0, and I'm going to pull groovy into where it says the number 1. If I don't actually give the numbers here, it will wind up behaving the way we think it should. This is a little bit strange to me, just see a bunch of empty characters and not even say what it is that we want from that. On 0, 1, on 0, I feel 1. Here's basically almost identical to what we had on our first line, except we have a list and not a set of arguments. What's going to happen here? There's an error. And why is that? Well, because Python is expecting you to have this argument, and you've given a list, so it only sees one argument, where it's expecting to see 2. It has no idea what to do with this 1 here. This is okay, Although this isn't really a nice thing to do, but because it's a little bit subversive for somebody that's trying to read your code. On 0, I feel 0. So what's the 0th argument to this format string? It's a list that says Saturday Groovy. On 0, I feel 0 format Saturday Groovy, it's only going to grab the Saturday. Okay? So remember before when I said, all these different ways of showing off math.py, math.py, I actually had to explicitly give it math.py, math.py, math.py. Now, if I know I just want to format math.py in a bunch of different ways, I can just give that as one argument and just keep referring to it in the string itself as a curly bracket 0. So you can assign by argument position, which is the 0s and 1s. Yeah?
All of your examples are strings. Do you have to cast it to a string already?
No, you won't have to. We'll see. I think I'll get to a couple examples of that. Yeah, I will get on the next page. So now let's say that I'm going to have this really long string, and I don't want to have to keep looking up. Maybe I've got a triple quote, and it's 3 pages long, and I want to replace a bunch of different places with some variables that I don't know their answer until runtime. Maybe what you want to do is instead of saying in the 0th place, I want to grab that thing, in the 1st place I want to grab that thing, now you can actually name the variables that you want to pull in. So here we're now giving it, again, a bunch of arguments, but now these look more like keywords. Desire equals fly me, place the moon. Desire to place, and instead of saying 0 and 1, I'm saying fly me to the moon. I'm grabbing by name these different variables that I want to stick in there. Yeah?
And you could have, in the format parenthetical, you could have had place first and desire second?
Yeah?
Okay.
You want to try that?
Well, no, but...
You don't have to try. Well, don't trust me. I'll cut and paste and make it easier. Oops. Okay, and you want to say, well, I'll just change it in the string itself, right? Okay. Desire to place, or else I don't want to visit place. Fly me to the, desire equals fly me, place equals moon, and you see that I'm grabbing twice place. Fly me to the moon, or else I won't visit the moon. We don't have to actually give it a, yes?
I was just going to ask, can you predefine desire in place before?
Yeah, that's what we're doing now.
Oh.
Yeah, so that's this line where we're actually just going to create, what type of variable is this? F? It's a dictionary, keyword desire, value place, and then, sorry, value I want to take you, key place, and value funky town. So desire place, and now you have to do this funny double star, which is essentially dereferencing the location of where this dictionary is. The only time we really have to think at all of the pointers. I want to take you to funky town. Yeah?
So if you wrote before desire equals something, say a particular variable that you the user can put in, and place equals something before, then do you have to ever mention them again, or can you just say the quote desire to place unquote and then dot format?
So you want to create a variable called desire and see if we can just make use of it.
Yeah.
And then you want me to say something like desire.
Yeah, and then dot format.
And what am I going to put in here?
Yeah, that's where I go. So can you predefine it without recalling it?
No.
Desire. Okay.
No, you have to, it's basically looking for a key. I mean, I could do desire equals desire.
Okay, so you have to do desire.
Yeah.
How do you get the apostrophe and won't?
The what?
The apostrophe and won't.
The apostrophe and won't. What I would do is, so you want to do something like, you want to do an apostrophe in there. There's two ways. You could do a /that, or what I would do just to make the code a little bit more readable is have a single quote in there and make these double quotes. Okay. So here's some formatting, and basically the same sort of formatting paradigm from the previous way in which Python was doing string stuff. More or less persists. It looks a little bit weirder here. So this is what I had before, where I had a %03.2. So it's giving me basically 2 places after the decimal place, and it's going to pad it out with some zeros. And I'm doing the same thing here. And what you notice is I have a colon, and then I have my format stuff after that. Everything before the colon is where you're basically giving it the key to look up. So here I could have put a 0, but I just left that empty. And these are identical, so the strings that they're creating are identical. Here is where I've explicitly said, give me the zeroth argument. So I'm going to grab out this shortened version of pi, and I'm going to format that. Now let me grab the first one. So again, I've ignored the 42. So I've had that in there. I just haven't done anything with it, which is nice because if you have this huge dictionary of stuff, and you know that on one line you want to print some stuff out, on another line you want to print another stuff out, you can just keep on passing the same dictionary and only make use of the variables as you need them. 42. You can do binary numbers. So again, I'm not going to be able to go through all of these different formats. If you need it, you'll know where to find it. Int, so it's a D. Hex is an X. Oct is a O. And bin is a B. And again, this is a sort of nicer way to do this instead of the way we're at it. Keep on saying math.py, math.py, math.py. Right, because I just keep grabbing the 0th argument. There's other stuff. I won't go into the details of all these different carets and things, but here I want to actually pad it out with not white space, but perhaps I want to pad it out with some character. In this case, pad this out with basically 11 characters in total, and then have a bunch of stars around it. I can left justify with padding, right justify with padding. I don't know what that does. Oh, that's right justify where I require that I have 11 characters. So it's not exactly the same, especially this left and right justify stuff and the padding with different characters. That's sort of new. But again, when you need it, you'll know where to find it. We won't have a lot of time to sort of get into the nitty-gritty of this. But I want you to know that it's available.
And it works in 2.7.
It works on 2.7, definitely. It may even work at 2.6.5 level. You may have to import something special to say use the new way of doing printing. But yeah, for all of you guys using 2.7, you're good to go. And this is the only way to do it in 3. Regular expressions. Those of you that know about regular expressions already sort of know all the syntax. Those that don't, there's no way I'll be able to teach all of that. The point is that Python has regular expressions, just very complex ways of doing string searches. So for instance, I can create more or less a compiled regular expression search through email. Remember that long thing that said check email? You can basically just find all the emails that are valid, and that works. And then I get one of my bad emails, and I don't get anything back. So I'm not going to go into regular expressions. I'm just going to say that you can create these very long expressions that tell Python when you use this on a string, go and try to do the searching on this. And if it fails, don't give me anything back. If it succeeds, give me something back. You can get the string back itself or something else. This is very powerful if you're parsing through lots of strings. You wouldn't typically do the, look for the dot, make sure there's at least one @ sign or only one @ sign. That's expressed through this crazy expression here. And you're not going to be tested on that. And by the way, I found out how you do regular expressions on whether something's a valid MasterCard or Visa. Do you know how when you're typing in online and you enter the thing in and put your number in and it's like, no, you said this was a MasterCard, this is actually a Visa? there's a little JavaScript somewhere that's checking in the browser and it's running that regular expression on your number. It doesn't know how much money you have associated with that card, but there is a rubric that both of those companies have for basically telling you how their whatever 12-digit number is valid or not. Okay, file I/O. You've already done some of this for your homework, where you had to open up a file and read it in through CSV to rec. But now, if you don't know what you've got in the form of this file, or you do, and it's not in comma-separated format, it's perhaps something very different, but you want to be able to get into the internals of that, there is a built-in called open and close. And it shouldn't be dot open and dot close. It should just be open and close. There is a way now, in fact, I think this is the only way in Python 3, using a module called I/O. So you would say import I/O. And then instead of saying open and close, you would say io.open or io.close. Don't worry about that. For now, you can just open up a data file, and you tell it how you want to be looking at that data file. R is for reading. W is for writing. You can do appending. You can open it up as in sort of as an ASCII, so essentially as a view with thinking that everything inside has ASCII characters in it. You can open it up as a binary. There's lots of different ways to do that. R plus is just the read plus update. RB is a read as a binary stream. So what is file stream? It is a type file. When I'm done with whatever I want to do with that file, I say file stream.close. Likewise, I can write. So I can say, let me open something called test.dat for writing. I can do basically write some string into that file. And you notice what you're doing is this F is now pointing to some place in memory. And when you close it, you're making sure that you're doing all the right things of giving the right permissions and making sure that it's happy on disk, etc. But the way to think about it is, when you open up what's called a file buffer, you're basically pointing to the beginning of an empty file. In this case, when I've done a write, and what I've done is I've just written strings into that buffer. I can close that. We can do import OS. os.system, cat just shows me that, and instead of knowing exactly what I'm going to, instead of just hard coding in the name of the file, we'll just use a little bit of the string stuff here. So what I'm going to do is I'm going to essentially run at the command line, but from within Python, cat test.dat. You could remember in IPython, if you're just trying to see how well you're doing, and you've just written out a file, remember you could do the exclamation point and then whatever you want to do on the command line. But this is how you would do it just in pure Python. This is my first file I/O. Oh, and I had a 0 at the end there. Anyone have any idea why that is? Yep, so the os.system returns to you whatever the result of it did here. It's capturing the exit code that comes out of that program, and that turned out to be 0, which is Unix's way of saying everything's fine. All right, let's get a little bit more into the nitty-gritty. Instead of just saying .write, I can have an entire long list of things I want to write out, and instead of writing line by line, I can just say write lines, and this will write lines for me. I can print that out, and I get the same thing. Yeah. What's that?
Do you need the backslash?
That's a good question. I actually think you may not need to have it. Let me just give that a try. So there it makes it seem like you more or less don't need it. Sorry, you do need it. Let's see what happens if I don't put that in there. Oh, I can't do that because I already closed the file. So it doesn't let me write onto a closed file. I guess that's good. So do we need it? Yep. Write lines is really just a statement of write this whole list and just do the looping for me. It's much faster if you've got a long, long list of stuff you want to write out. It's much, much faster to write it out using write lines than to just say, do a list comprehension, because all that stuff is happening for you at the C level if you say write lines. The other way in which I think about interacting with files is typically what you'll wind up doing in other programming languages is you'll open up the file and then you'll sort of interact with that file and say some big loop, right? And then at the very end you close the file. What I usually wind up doing is I open the file. If it's not massive, I'll read it all into some buffer. I'll read it into some variable, and then I'll just close the file immediately, and then I'll just do all the stuff I need to do with the actual the variable itself. Another way to think about that in the context of writing is that let's say you're going to be writing the result of some long code that you have been running. And if you're pretty sure that that code isn't volatile, isn't going to break, and you don't need logging, you don't need sort of checkpoints, let's say you want to accumulate all of the things that you want to write into a file. What you might do is load up your own variable, your own list of what you would like to write, and then just at the very end, open up a file, do write lines, and close it, rather than keep a file open for the whole time and in turn do your writing of the lines throughout your code. There's read lines and read, basically symmetric with write and write lines. So we can open up some data, read it in, close it down, print it out. If we said just read, so f.read, that would mean that we're only going to read one line, and it would wind up looking until it gets to a \n. Okay, we're going to play around with another file which should be on the website. It's called Tabify My CSV. It's, I think, well named, and it has some doc strings in it. It tells you what it does. Essentially, we're going to wind up taking a file in. We're going to write out another file, and we're going to more or less take it from being a comma-separated file to being a tab-separated file. So it's a small copy program, as it says, that turns CSV file into a tab file. All right, so let's step through this. First of all, how many arguments are there? 2 arguments, and how many keywords? Yep, we got 2. And so the default for ignore comments is true, and the comment characters, these are the ones that we might ignore, are these guys. We could add more if we wanted to and change that. So if not ospath.exists, what do you think that means? The file isn't there, return, and don't do anything. We could say, we can give them something more verbose. Let's open up a file, and let's open up another one that we're going to write to. Inlines, read lines, f.close. You notice I just read it in and I closed it right away. So now inlines has all those lines. Outlines is now an empty list. Yeah?
Inlines and string are right.
What do you think?
String from the previous example.
Well, it's read lines, and write lines was we wrote out a list with write lines. Read lines will give you back an array. Yeah. And if it turns out there are no \n's, it will give you an array of length 1 with the whole, basically the whole buffer. For L in inline, so I'm going to now loop through all the lines. If ignore comments, and the first element of that line is in the comment characters, I'm going to wind up appending it directly. So even if I have tabs and commas inside of those comments, I'm going to just ignore those and just faithfully reproduce those comments. And I'm just going to append that string into my list of outlines. You notice I'm not writing each time into the buffer. That would actually incur a bit of a file I/O overhead. I'm just writing it into my variable called outlines, my list. Otherwise, take that line and replace all the commas with \t's. And when I'm done, write the lines and close the output file. Yeah?
For a previous program, didn't we find the string?
No, read lines should give you a list back.
When we print data, it shows the string.
Well, so let's see. We've got more test data, right? Let me write out the test data. By the way, I'm pressing the up arrow. That's kind of nice. IPython has some of the readline stuff that you're used to if you're working in, say, a bash shell. And by the way, you can also do Control-R to search back into your history in IPython. So I can search for close. I just start typing close, and it finds the latest one. If I do R again, I get another one. Okay, so let's take a look at that. Or test.dat. Okay, so that has a couple different lines on it. And what are we going to do? We're going to say O equals open test.dat. I want to read this in. O read lines. Okay, so it returned for me back a list. By the way, if I quit out of IPython, it didn't say, you've got files open, and it's not like I set up race conditions. One of the really nice things about Python that we haven't really spent any time talking about is all of its garbage collection, right? I had an open file, and I just quit out of Python. And Python said, don't worry about it, I'll take care of all the stuff you left open. All of your little pointers and things I'll deal with. So it's dealing with all that stuff for you, and you don't really have to think about it. So let's take a look at the Google share price. You see it's got a comment on it, and it's got a bunch of different numbers. It's a little bit similar to what you had before with your trends for your homework. Then we look at the output if I run this Tabify on it. I get back what I expect. Okay. A little bit more about file I/O. One way you might think to copy one file to another would be to sort of open it all up, put it all into memory, and write it all out. There are nice utility functions that you can use that do this very efficiently with low memory overhead. It's very quick. shutil module is the thing that you want to look at if you're going to be doing lots of sort of file manipulation where you're moving things around within your OS. Sometimes you need to build up a temporary file, and you want to make sure they don't just call it /temp/test.dat. Because what if you have 10 versions of your code running at the same time and they're all sort of using the same thing? So you need essentially a random test file name, and you can do that with a module called tempfile. Again, as soon as you say, what I'm about to code, maybe somebody else in the world has done this over the last 10 years, there's probably something within Python to do it. Tempfile is a built-in module for Python, and I often use it. So here I'm just going to create a temp file. What is type of temp? It is of type file. So I just get back essentially an open file pointing to somewhere. If I want to actually name that file, so if I want to just write into that temporary file, do stuff with it, and then be done with it, and I don't care where it lives on memory and stuff, you would use temporary file. If you actually want to name it so that you can actually look at it later, or actually pass the name of that file around to another function, you can do that as well. You can say how you want the file name to end. You can say where you want to stick the file in the form of the dir keyword. You can say when I'm done with the file, as in when I close the file, whether I want Python to automatically delete it for me or whether I want to keep it around. And the prefix will be boot. And temp.name, which is an attribute of this file type, is something. And if you run this exact command right now in your own interpreter, you're going to get something very different, except the first 4 letters of this file will be boot, and the last 4 characters will be .csv, because that's how we've told it to behave. And it's going to put into this /temp directory. So I can write I can write into that file if I'd like to immediately. So I'm going to basically create a comma-separated file with a comment, stock phrases of today's youth. For instance, what's up, OMG, LOL, BRB, Python. Temp.close, and now I'll actually take a look at that file. Oh, and I got a 0, right, because I have the OS.system. Sometimes you don't actually want to write into a real file on disk. Perhaps you just want to write into something that behaves like a file so that you can pass it around across your code base. And while you're sort of working in your runtime environment, that sort of object lives as if it was a file on disk, but it actually is just someplace in memory. And string I/O is used very often for this. It's handy for making file-like objects out of strings. And for those that are used to thinking about files as buffers, where you can sort of jump around to locations within the buffer, things like seek, where you could go to the beginning or the end of the file buffer, that stuff all kind of works within string I/O. Even though you're not actually interacting with a real file, you're interacting with something that looks like a file to Python, but is actually just some big chunk of memory somewhere. So import string I/O, my file, string I/O, stock phrases of today's youth, etc. We can get what we've just written in. We can seek to the beginning of that file. We can do read lines on that file. I can close that file, and I can write to that file, except I closed it, so that's not good. So let me open it up again. I can seek to the second location of that. I can write silly inside of, starting at the second location, seek back to 0, read out what I got, and you see that I replaced stock with silly.
Even though strings are immutable, the string I/O is.
So this is not a string in the sense that you're interacting with this as if it's a file, and you're interacting with it as if it's a file that's open, that's in memory. So when I actually say, instead of saying silly, if I'd said supercalifragilisticexpialidocious, it would overwrite all the characters that are there, and it wouldn't make the whole thing larger. I always wanted to say that, and now I'm done. You can retire. C string I/O is a faster implementation, a bit more memory efficient, but it's not sort of cross-platform independent. I believe it works on all Unix flavors and Mac. I think it's got some volatility with Windows. So typically what you'll wind up seeing if you are going to use string I/O is you'll see something basically where you have a way of saying, try to import C string I/O. If that doesn't work, just import string I/O. We'll show you an example of that in 1 or 2 modules. Another useful interaction that you need to do, obviously, is make calls and have discussions with your OS. And I already showed you os.system. That is not a preferred way to be doing things at the command line from within the Python interpreter. Instead, the preferred way is doing something called subprocess. And there's lots of different things you can do with subprocess. Essentially, the way that you think about your interaction with the OS is that you're basically going to start up different processes. Sometimes you want to push stuff into that process as if you were sitting there at a terminal and typing stuff. Sometimes you want to receive things back from it, so you want to get the standard out from that. And sometimes you want to be getting the standard error. And all of those are considered sort of different streams from a Unix perspective. But what you do is you basically open a process, that's popen. And here I'm opening up ls, or if you're in Windows, you would say dir. I want to create the equivalent of a shell when I do this. And I want to have the standard out go to something called pipe. I get a process ID, so if I want to watch how that process is going, I can, as you'll see, we'll be able to wait for that process to finish. It's got some process number. Yours will be different when you run this. I get a standard out, so p.standardout.readlines. I get all the results of what's in my directory. If I want to run something called Spamalot, which is an executable that does not exist, I'm going to get the standard out and the standard error. and Spamalot command not found. Okay. You usually, especially if you got something that's going to run for more than a nanosecond, like an LS or something, perhaps you actually want to go off, do an email, check a web page, write some file, and then come back to the Python process. You usually want to return basically after you're done. So if I just say find everything with the .py at the end, I can wait until that process is completed, and then I get my full listing out. If you don't wait, there's a chance that because you basically can return right back from the call to popen, you can actually get results back from the standard out before this whole thing is completed. So if you want to wait until the process ends, you just do this os.waitPID, because now I know the process ID of this process that I spawned off. Yes?
So if you just do read lines, it's not going to make sure it waits until the process is done? If you
just said read, typically if you're interacting and you don't know how many lines you're going to get back, I would just say read. And if it takes an hour to get it back, and you just keep on looping through and you read every 1 minute, you'll just keep on building that up. But typically, if you want to interact with it that way, that's fine, right? Which is really nice because it means you could have an asynchronous discussion with some other process. And Python could be actually acting as a surrogate for a person, for instance, by doing standard in and writing to standard in, which would then get taken up by the sub-process. Yeah?
What are the other options for SDE and
I don't remember, but let's figure it out. I've never used it any other way. You might, as Brad's saying, you might be able to pass it a file handle. So subprocess popen ? I think the way we should do this is by looking at the documentation. If we want to do that, we can do that. Oh, I'm not online. The documentation on that gives lots of different types of examples of how to use subprocess. I've almost exclusively used it just to replace what I used to do with OS system. And there was something called popen2 and popen3. But this is more or less, I need to start up some other thing somewhere else. This is where Python comes in as a glue. I need to run stuff, get the results back, and just deal with it within Python. But I think you can do very complicated interactions using subprocess. Okay, it's breakout time. You're going to build a command line utility file which copies the input file to another file. And it does crazy stuff to it. Reverses the ending of the file. So if it was called josh.dat, it's copied to josh.tad. Deletes every other line. Changes every occurrence of the word love to hate. Not to is to not. Sets every number to half its original value. So if you see 3.14 and you like 2, you should say something like 1.57 and you like 1. Count the number of words astrology and physics. And we'll post in a minute a file called le.info onto the agenda site. But you can start coding this up just to get the whole infrastructure there.
It's on there.
Okay, Brad has posted it. Any questions about that? This is a silly one, but it's just trying to get you used to dealing with reading and writing out and getting into files and messing around with strings. Welcome back, everybody. Good to see you. Let's see how we're doing here. I had a couple of corrections from last time. First of all, I want to just, there was some confusion towards the end of the day when people were starting to get their teeth into the notebooks. And they wound up noticing that sometimes you could download the notebook and then you'd bring it up and then it just wouldn't even render at all inside of your web browser. That's because there was a version change from version 2 of the notebook to version 3 of the notebook as IPython itself went from 0.12 to 0.13. Unfortunately, the latest EPD distribution is 0.12, so The vast majority of you, I think, are using what you might call an old version of the notebook. The new versions of the notebook will be able to read the old versions, but the old versions don't know how to read the new versions. So accidentally, we posted a couple version 3s and not version 2s of the notebook. So if you're having trouble, it's not you, we just posted the wrong version. What we're going to try to be diligent about, and you see Eric did this already for the solutions, is to post 2 different versions of the notebook. If you're using the latest IPython 0.13 or 0.14, you're fine to pull up either of those. If you're using the EPD distribution, make sure you get your hands on the version 2, okay? And if you find out that we haven't posted the right one, just let us know. The other one is I impugned the state of Kansas yesterday, and I apologize for that. I got an email from the governor, and you as well. It was actually Indiana that tried to pass the Pi bill. And it wasn't 3.0 that they try to say. Start off with the string, split it up, and the result of that is a list. We iterate over that list, and as we step through each element in that list, we basically fill up this variable called x. And then we wind up running the capitalize method on that. And then you wind up getting a new list that comes back where you've capitalized each of the words in turn. I want to take you to Funkytown, and now I don't want to split it on all the spaces. I want to split it on something else. I want to split it on U. And so what you wind up seeing is every time there's the letter U, you wind up removing that and splitting on that. So now I've got I want to take Yo to F town. What if I want to split on not just an individual character, I want to split on a string? I can do that as well. And it says I want to take, and then you notice that it's preserving that space right there to Funkytown.
Josh,
Yeah.
can you split on the character can you keep the character you split on?
No, you can figure out sort of very succinct ways of pushing it back on when you actually, if you want to say rejoin the strings or something. But no, effectively what you're doing is saying use that to cut stuff. And you can imagine why this might be helpful, say, if you're parsing through a CSV file and you didn't know about CSV to rec, you could go line by line and say split on commas. Or if you know that your CSV file is tab separated, you could say split on /t. And here we go. So here's a CSV string. Dog, cat, spam, defenestrate, 1, 3.14, and then some other stuff at the end. So we can say CSV string.strip. And what does strip do? That's something new. That just removes all the trailing and leading white spaces in a string. So that's kind of nice if you want to clean up individual strings. Now, let's say I want to clean up that list a little bit, and I want to make, I basically want to make sure that I don't have extra spaces after I do my cut. And so I have my clean list, and what have I done? I've taken CSV string, I've split that on the comma, and then I will wind up iterating over that and making a new list. What does clean list look like? It looks probably something similar to what we want. Right? So now you can deal with each of the elements of this. So, you know, one way to think about you parsing foreign data is that you have to be pretty robust against all the little quirkiness of that data. And so this is actually pretty easy. After you've played around with a couple lines of a piece of data, you'll wind up realizing, oh, there's all this stuff at the end. I don't really need that. I can get rid of that. They've added all these extra white spaces, which isn't really nice. And so, this is part of you getting familiar with the data sets that you're playing with. This is mostly in kind of reading stuff in. There's similar kinds of things you do when you write stuff out. In particular, there's something called join that allows you to glue a list of strings together with a certain string. So now I've cleaned up that one line of CSV, and I want to do something with that. Let's say I want to write back out a cleaner. Pi was, they said it was 3.2. It almost passed. So I apologize to everyone from Kansas, but now I'm looking at you in the end. Okay, so here's the plan of action for today. We are already a couple minutes behind. We'll try to catch up a bit. We're going to talk about strings. In some sense, we kind of powered through some of the real basics of the Python language yesterday. And then we got into some interesting stuff like plotting, and these are considered sort of outside of the built-in core language. We're going to come back into the core language in the morning and really spend most of the day sort of teaching you some of the more advanced concepts that exist within Python. And then tomorrow we'll get back into some of the more advanced stuff that lives sort of outside of the core language. So this morning we're going to do advanced strings and file I/O. We'll do some advanced stuff, just sort of a grouping of things that we think you should know that weren't in any of the other modules before we do the first introduction to object-oriented programming. Then we'll have a lunch and a breakout. We'll do another incarnation of object-oriented programming, getting into some of the nitty-gritty of that. And then we'll end the day with some software carpentry, a discussion of development of your code, versioning of your code, and curation of your code using the thing that we all use, which is called Git. Okay, so let's jump right into it. Strings can do operations on themselves. You've already started to see this concept of a method, but now we're going to see what strings know how to do on themselves. So if I have a couple of different methods on strings, one's called lower, another upper, another capitalize. Funky town, you see I spelled that, or at least capitalized that in a weird way. You can say dot capitalize, and you get funky town. Here I have another funky town. I can put it all the lowercase. I can split up strings very nicely and elegantly. If I just say funky town and I say dot split, it splits on something. There's a default. There's a character that it splits on. It's basically it's a space. So every time there's a space in your string, it will split there. And what did it return? What type of object did it return back to us? A list. And a list, or an array. But it is technically a list. So I could iterate over that list if I needed to. You can daisy chain these methods, right? Because the result of having return capitalize is a string. And so I can, if you want to think about it this way, what's happening is you've got the result of what's ever happening inside here, then getting returned into a new string, which is then getting split up. You can use the list comprehension that we introduced yesterday to go through and perhaps sequentially capitalize each one of these. So you notice, if I said funkytown.split.capitalize, the result of funkytown.split is a list. .capitalize is not a method of a list, and so that would fail. So if I really want to capitalize each one of those letters, each one of those words in turn, one way to do it would be to